But this is where we make the most mistakes. All right? And again, if you guys just follow along with my process, we got to first set this equal to 0. So what I'll do is I add 14 to both sides. So therefore, I have 4x squared minus 18x plus 14 equals 0. Does everybody follow me? OK. So now we need to factor this. Now, usually, technically, students, they get pretty good at doing this method. But there's something that's different about this problem compared to the last problem. Last problem, we just had x squared. This problem, we have 4 times x squared. So you guys can see we now have an a, right? There's an a. A was just 1 in that last example. So we didn't really have to include it. So if you guys look at this bx plus c, just to kind of go back to that, we're still going to do what we did before. But now, instead of finding what two numbers multiply to give you c, we're going to have to figure out what two numbers multiply to give you a times c, but then add to give you b. So let's do a times c. 4 times 14, 28. That's going to be 56. So I got to figure out, yes? Oh, we can actually factor out the GCF, which I told you to do, which I didn't do, right? Very good, very good. That's exactly what you'd want to do. That doesn't go along with the type of problem, though. Oh, that's what I did for those other two problems. OK. Let's go ahead and do it that way, just real quick. Yeah, you can, well, you can factor out a 2. OK. Very good. I like that idea. Let's factor out the 2. Sorry about that. I wasn't paying attention, which I should have. If you factor out a 2, yes? OK? You can divide out that 2. So therefore, you're left with 2x squared minus 9x plus 7 equals 0. Does anybody have any questions on what I did? I kind of got tunnel vision, and I stopped looking at the problem. Was everybody OK with what I did? I factor out the 2, which is the GCF, which I told you to do, which I just didn't visualize, didn't see it. Then I just divided the 2 out, so therefore it's not really going to cause an issue. So let's go back and let's revise this again. ax squared plus bx plus c. We still have to do a times c. A is 2 in this case. We still have to do it that. However, we're not trying to figure out 56. But since we factor out that 2, we're now trying to figure out what two numbers multiply to give me 14, but then add to give me a negative 9, right? And hopefully you guys can think of this in your head. But if you can't, start listing out all the numbers that multiply to give you 14. 14 times 1, 7 times 2. That's it. Now, remember, if they add to give you a negative number, then both those values have to be negative, because they also multiply to give you positive 14, which I didn't write up here. So the two numbers that multiply to give you that are going to be negative 7 and negative 2. Do you guys agree with me that negative 7 times negative 2 gives you a positive 14, which is a times c, but then they add to give you negative 9? Yes? Yes. OK. Here's where we get the big mistakes come in. Dang it, I'm dropping everything. So majority of students will come and they'll say, all right, Ms. McLogan, I found them. These are just as easy as the last problems. And they give me that. The problem with this is x times x gives you x squared. It doesn't give you 2x squared. Negative 7 times negative 2 gives you 14. It doesn't give you 7. So these are not your factors of this. When a is equal to 1, yeah, that works. That's how we do it. But when a is not equal to 1, we can't do it that way. Does everybody see that? Because it's such a common mistake. Students will take those two numbers and plug it in. So then what do we do, Mr. McLogan? Well, we're going to utilize these. We're going to utilize these two factors, but we're going to utilize them in a special way. And what we're going to do is we're going to break apart negative 9x, our middle term. Does everybody agree with me that negative 7x minus 2x is negative 9x? Yes? But why do we break it up like that? Couldn't we also use negative 8x minus x? We could break up 9x that way, right? But negative 7x and negative 2x is the only values that gives me negative 9x, but then also multiplies to give me 14, which comes from a times c of our original problem. Yes? So we're going to use these values to rewrite our middle term. Then once we've rewritten our middle term, you can group the first two terms and the last two terms, which is going to be called by grouping. Now all we simply do is factor out the GCF of the first two terms and factor out the GCF of the last two terms. So what does 2x squared minus 7x have in common? Yes? Yes?
Would it be easier if you switch the 2, put it on the other one, because then you have 2x, take it off?
It doesn't matter. It's going to work out the same no matter which way you do it. But yeah, you could do it that way as well. Yes?
Shouldn't there be a cube there?
A cubed?
A cube, like you put 2x squared minus 7x multiplied by negative 2x.
No, I'm not multiplying them. I'm just grouping them.
Oh.
I'm not multiplying. I'm grouping them. Because now what we're going to do is we're going to look in here. We're going to say, what can we factor out? Which in this case, you can factor out an x. When you factor out an x, you're left with a 2x minus 7. Over here, again, the only thing I can factor out is a negative 1. And that's going to be left with a 2x minus 7 equals 0. Now, what I want you guys to show you is when you factor that out. Sven, are you OK? Sven? Oh, OK. So you guys can see that now each of these now have an expression of 2x minus 7 times x minus 1. So you factor out their common element there. Now, do you guys agree with me that 2x times x gives you 2x squared? Yes. Negative 7 times negative 1 gives you a positive 7? Yes. The middle terms multiplied to give you a negative 9x. Now you can apply the zero product property. To save some time, I'm just going to set them equal and be done. Ladies and gentlemen, I had to go and show you the longer method. I will not be doing